Hi guys. Today we are going to take solving a little bit further. So far we've looked at solving equations and solving inequalities with one variable, and today we're going to look at absolute value. So let's take a look at something basic. If we have the absolute value of x equals 5, the absolute value basically says the distance the number is from 0. So if we think of x being absolute value of x being equal to 5, x could be one of two things. It could be a positive 5 or it could be a negative 5. So we need to keep this in mind when we're looking at some of these equations. So let's take a look at a simple one-step equation. If I give you the absolute value of x plus 4 equals, let's say, 8. Inside this absolute value bars, this number right in here, that can equal 8 or it can equal negative 8. So what we do here is we want to separate this into two equations. We're going to solve an equation where x plus 4 equals a positive 8, and then we're going to solve the equation x plus 4 equals a negative 8. So when we solve over here, we go back and we're going to subtract 4 from both sides, so x equals a 4. When I subtract 4 over here, x equals, be careful, you got that negative 8, it equals a negative 12. So for absolute value equations, you're always going to have two answers here. Okay? Let's do another example. This time, let's do the absolute value of 8 minus x equals 1. So again, inside the absolute value bars could really be 1 or it could be negative 1. So we have, excuse me, I'm in my throat. So we have 8 minus x equals 1, and then 8 minus x equals a negative 1. Again, continue your solving process. We're going to subtract 8 first, and remember you take the sign that's in front of the 8, so we're going to subtract 8. We get negative x equals a negative 7. Last step is to get that x a positive, so we're dividing by a negative 1, so this is going to be a positive 7. Over on this side, we're going to subtract 8 from both sides. Oops. And we have negative x equals a negative 9 this time, and then divide by negative 1, so x equals 9. Again, we have those two answers here. Okay, let's try one that's a little bit more challenging. It just has an extra step in it. So we're going to do the absolute value of 10x plus 2, and then minus 18 outside the absolute value bars equals a negative 12. Now the thing here you need to remember, inside the absolute value bars has two possible answers. So we need to get this isolated by itself before we can create our two equations. So we're going to start by adding that 18 to cancel it off of the, the left side and move it over to the right. So when I look at this problem now, I have the absolute value of 10x plus 2 equals 6. Now at this point I want to create my two equations because I have 10x plus 2 equals, plus 2 equals 6, and I also have 10x plus 2 equals a negative 6. So when I go back over here and solve, I have 10x equals 4. And don't forget, you're always dividing the number that's next to that x, that coefficient in front of x. You're dividing by that number, not by the smallest number, by the coefficient of x. So when I solve this, I'm going to get x equals, simplify 4/10, which gives you 2/5. Over here, I have 10x equals, I'm going to subtract 2, so I get negative 8. Again, divide by 10. So we are going to simplify negative 8 over 10, which gives you negative 4/5. And remember, fractions are answers. They are allowed. You're allowed to have fractional answers. You're also allowed to have answers of x equals 0. Okay. All right, now let's take a look at, just going a little bit further with this, take a look at an absolute value inequality. So let's start with the basic one again. So we have the absolute value of x minus 4. This time I'm going to say it's greater than 1. So with absolute value equations, you can still have two possible values inside the absolute value bars. So we are still going to separate But this time, I also need to take into consideration this inequality symbol. So when I separate this into my two equations, I have x minus 4 is greater than 1. When I go over here and I do x minus 4 and I set the inequality equal to a -1, I then also need to flip this inequality symbol. So I need to take the reverse. So I'm going to now say is less than a -1. So whenever you do the negative, you have to change the inequality. So let's go back over here and solve this. So I have x is greater than, I'm going to add 4 to both sides, so x is greater than 5. Then I'm going to add 4 again to both sides, so x is less than 3. Let's take a look at that on the number line. Oh, sorry about that. If I look at that on the number line, I have 2, 3, 4, 5, and 6. If this is our number line, and I'm trying to graph this, x greater than 5. First of all, remember, we already talked about this the other day, that if you have a greater than or just a less than, it's going to be an open circle. So x is greater than 5 is going to be an open circle, and we're going to be shading to the right. If we also have x is less than 3 as a possible answer, they're going to go on the same number line. X is less than 3 is again going to have an open circle, and we're going to be shading to the left. So we talked about compound inequalities the other day as well. So what kind of inequality is this? Well, this ends up giving us an OR statement. Here's a little trick. If your inequality sign right before you create your two separate equations, if this inequality sign is greater, and I'm saying that with a little accent, greater, then it's going to be an OR problem. If it's less than, it's going to be an AND problem. And again, that's the sign right before you separate it into two inequalities. Okay, so let's try another one. If I start this one off as the absolute value of x plus 5 is less than or equal to 7. Look at our sign. Look at the problem. Do I need to take any initial steps before creating my two equations? No, I do not. I don't have anything being multiplied or being added or subtracted to this absolute value. So I'm going to start off right away by creating my two inequalities. So since that's the case, if I look at this sign and it's a less than, then my inequality graph should be an AND statement. So let's just make sure that we do get those types of answers. So my first equation is going to be x plus 5 is less than or equal to 7. And my second equation is x plus 5 is greater than or equal to a -7. Notice how I'm never changing any of the signs inside that absolute value. Nothing changes in there. It's only the solution that changes. So then if I go back over here and I do x is less than or equal to, I subtracted 5 over, so less than or equal to 2. And again, I'm going to subtract 5 over, and sorry, let me fix that. When I subtract 5, I'm going to get -12 this time. So if I look at my graph here, I'm going to start down at -12, and I'm going to count by 2, so -10, -8. Okay, so when I graph this, if x is less than or equal to 2, so we're going to put a closed circle, remember, and less than is going in this direction. If x is greater than or equal to a -12, closed circle again, and it's going in this direction. So it's going to be an AND statement, which means we're shading everything in between. Sorry, I just want to make sure that you can see that where I'm shading. So I'm shading everything in between. Okay? Any questions? Hope not. All right. Next example. Let's do a little bit more challenging one. I'm going to put a -2 out front, and then we have an absolute value of, oops, just put in 4 in there. 4x plus 1 is greater than or equal to -4. Now, this one has something outside, so I always need to get rid of anything that's being multiplied or added or subtracted or even divided by this absolute value or to this absolute value. So in order to get rid of this -2, I actually have to divide because it's being multiplied. So when I divide by -2, We do have that one simple rule. We talked about it the other day, or earlier today. The one simple rule is that when you divide by or multiply by a negative number over here, that you need to change the inequality. So flip that inequality again. So if I have the absolute value of 4x plus 1 left on my left side, it's now going to be less than or equal to 2. Okay? So now, at this point, now I can use that little trick, that greater or less than trick, because this is now going to be the inequality that I'm looking at right before I create my two separate equations. So since this is a less than problem, this is actually going to be another end statement. So when I create my two equations, I have 4x plus 1 equals, oh, I'm sorry, not equals, is less than or equal to 2, and 4x plus 1 is greater than or equal to a negative 2. And here we go again solving. If we do subtract 1 from both sides here, we get 4x is less than or equal to a 1. And then keep going. Remember, you're dividing by the coefficient of x, so x is less than or equal to 1/4. Over here, we're left with 4x is greater than or equal to a negative 3, and x is greater than or equal to a negative 3/4. Okay, I'm not going to actually graph this one because really we're not going to be having a lot of these fraction ones, and also we're going to have plenty of time to practice them later on in class. I think that kind of covers all types of inequalities and absolute value problems that I wanted to discuss today. So if you are finished taking notes, if you don't have any confusion or any questions, then you can log off the computers and we're going to get started on some practice problems.